So, all right, good morning, everyone. How's everyone doing out there? Let me know if you can hear me all right by saying, I can hear you, or hello, or something. It's a good way to let us know. Anybody? You can hear us? Cool. All right, so welcome again to this is our 5th installment of Live Science here at Chabot Space and Science Center. As you know, my name is Haley and I'm a science educator here at Chabot. Today I have another Skyline GE joining us today. His name is Daniel. Can everyone say hi, Daniel? He's going to be helping me out doing our demonstration today side by side with me. And we're going to get into some of the science that we're doing. So today, as you know, live science. What is live science? Well, we're going to be doing a live demonstration of some scientific concept, reaction, or theory. And what we need from you as our audience is to make observations of what you notice happening, to make predictions of what you think might happen next, and to make explanations of what you think the science is of what we're doing here today. So we need your help as fellow scientists to help us out. Now, during this time, we are currently working on our reopening plan to reopen to the public. So we are hosting a bunch of live events, especially coming up during this time. We actually have a really special time of the year here for Chabot because we are celebrating our 20th anniversary up on Skyline Drive. So at our current location, we have been here for 20 years. Woo! That's super exciting. So we are going to be hosting an event to celebrate our 20th anniversary. We are also hosting a live auction right now throughout the month of August where you can bid on special events such as Party with the Scientist with me. I can party with you for like your birthday, of course. But you can bid on an event to have me come to a birthday party for you, and we can do something like this virtually. We also have some moon prints that were used in our Luminous Moon exhibit last summer. You can bid on those moon prints as well if you're interested in getting a beautiful piece of art in your house. So those are some of the things we have going on. We also have live telescope viewings coming up on the weekends, so feel free to tune into one of those as well. So that is our current schedule, and that's what's going on. But for now, I just want to say that we are going to get started, double checking with our crew to make sure everything's all right. Daniel on Facebook, but okay. Maybe
I'll pin it when it needs to go.
Okay, so we can pin between myself and Daniel. We'll try to make sure we can see both of us. So for now, we're going to get started. But before we get started, we need your help in determining what kind of safety gear I need. So let's warm up our fingers in that chat section, either on Zoom or Facebook Live. Go ahead and tell me, if I'm going to do science today, what are some things I might need to help make sure that I'm going to be safe?
Janice says gloves.
Janice says gloves. That's a good idea. We are going to need some gloves today for some of our demonstration. So Daniel and I are going to put on our gloves.
Jack, the best kid ever, says that goggles and coat.
Oh, Jack, the best kid ever, says we need some goggles. So luckily I have some goggles here. It's a little different than what I usually wear. And we both already have our lab coats on, myself and Daniel included.
This one's good. Rihanna says not nice clothes.
Yeah, not nice clothes today. I did put some food coloring in my water here. So yeah, I wore all black so I don't get dirty. Always important. Anything else? We are wearing masks to make sure that we're safe because of COVID-19. We want to make sure that we're practicing social distancing, which is why I have Daniel on the other screen. And we're wearing masks as well. And anything else? We're not going to need it today, but I do have a fire extinguisher. It's actually propping up my computer. So we're not going to need it, but we do have a fire extinguisher on hand just in case. Now, what we're going to do is we're going to get into our demonstration. And while we do our demonstration, we're going to walk through it. I'm going to kind of explain what we're doing, but I'm not going to explain any of the science behind it. So we're going to need your help to make observations of what you're seeing what you notice, what you think is going on, and then we'll explain it when we're ready. All right, is everybody ready? It's gonna be a pretty cool one today. All right, so the first thing we're gonna do is we're gonna introduce the material that we're gonna use. We have two main materials today, but the first one, we're gonna grab a piece. And Eric, if you want to pin Daniel. We're gonna grab a piece and we're gonna bring it up close to the screen. This is one of the materials that we're gonna be working with today. So if you were here earlier during the Life Science series, you may have seen this material already once before. But before we explain what it is, or before you make a guess, go ahead and share any observations of what you notice about this material. What do you think about its color, its shape? What about anything that you notice happening to it? If I hold it up in the light, maybe we can see a little different. Ooh, I'm already seeing a lot of good explanations and guesses about what this material is. So we do have this white, almost looks like a rock material. It's kind of, it's steaming a little bit. And I've seen some really good guesses, but I'm not gonna reveal yet. What we're gonna do with this mystery material is we're gonna drop it into one of these containers. And these containers are just filled with water, just to explain that right away. But we're gonna drop it in. And what do you notice? Now, if you were here on week 2, you may have already seen something like this, but don't worry, we're gonna take it a little bit further today. So you may notice, and the dye makes it a little hard, but we've got this nice steamy material coming off of the top. So those of you that know what we're doing, maybe you know what this is, what's going on. We've got this foamy steam. All right, and now we're going to introduce our second material, which is this blue liquid that we have, this mystery blue liquid. So I'm going to hold it up real quick. Got a blue liquid. Maybe you make observations of its color. It's like a sloshing around in there. It's kind of hard to make any observations, but we'll just move on to what we're gonna do with this blue liquid. So what I'm gonna do is I'm actually gonna take my gloves off. And we have a shoestring inside of our blue liquid. I'm going to take our shoestring and we're gonna run it across the top of our container. And what do you notice happening? See if I can pin Daniel. You can see Daniel's. Are you able to see Daniel's? Okay. I'm trying to figure out how to get it to. I pinned him on mine.
Kids.
All right, so what did you notice as we go across? Does this give you any clues on what this material might be? Does this give you any hints on what this blue liquid was that we used? Soap. We got a guess of soap. That's on the right track. What was that?
Dish soap.
Dish soap?
Soapy water.
Good guess, soapy water.
Bubble liquid.
Bubble liquid? Oh, I'm hearing it.
And we think that it's dry ice.
You think that it's dry ice? All right, y'all are right on track. This is a pretty simple demonstration today, and you have figured it out. So what we have happening is we have a combination of dry ice, which is what we're putting into our water, and we've got soap. We've got bubble soap that we're using to create what we like to call boo bubbles. We like to call them boo bubbles because they look like tiny soap ghosts. They're pretty funny. So let's get into the science a little bit more since you already figured it out. we're gonna continue making our little blue bubbles here. And Daniel, do you actually wanna come over to my screen and you can help do these while I explain some of the science behind it? So we're gonna have Daniel come on over to my screen, and Daniel's gonna help kind of refill these bubbles as I explain some of the science. And then, if we're feeling brave, we're gonna try to make one of these into a blue bubble. So, we have a very cool material that we're working in, that white, icy looking material. That is dry ice. And dry ice, does anybody remember, if you've seen this demonstration before, does anyone remember what dry ice is made out of? If you know, type it into the chat. What is dry ice actually made out of? Something you may be familiar with, something we create. What is it made out of?
CO2.
It's made out of CO2, also known as carbon dioxide. So dry ice is made out of frozen carbon dioxide. And carbon dioxide typically is a gas. It's something that we breathe out. We exhale it when we breathe. We also can produce carbon dioxide gas when we burn fossil fuels. And carbon dioxide gas is very cold. It's negative 109 degrees Fahrenheit. So it's super, super cold. Now, dry ice is a super special ingredient or material because it has a really interesting reaction to water. This is something called sublimation. Now, what sublimation is when you have something like a solid, like an ice cube, turn directly into a gas, like a cloud of vapor, like we're seeing right here. Now, dry ice is not made of water, it's made of carbon dioxide. So if I grab a piece and I put it on the table, just put it right here, dry ice will never, ever, ever melt into a liquid. Unlike a water ice cube, which over time that solid ice turns into liquid, it melts, and then it evaporates into a gas. Dry ice only sublimates between a solid and a gas. So when we put it in the water, it creates that carbon dioxide gas that's white. That's because it's happening very quickly and very rapidly, and it's creating that thick, dense white fog almost. Because the water vapor is also getting mixed into that process. But today we added in bubbles. Now, the bubbles is where it gets a little fun. When you think about a bubble, I'm going to need your help to figure this one out. What do you need to make a bubble? What are the ingredients that we might have inside of our bubble solution that we use to make bubbles? And while you type that in, I'm going to add some dry ice into our big jug. Yes, Natalie, what do you think?
Somebody a while ago typed in glycerin.
Glycerin? So to make a bubble, sometimes we add glycerin, which is actually a really special ingredient. It makes bubbles even thicker.
Air and soap.
Air and soap, good guess. What else? Anything else? Air and soap,
Soap and water.
soap and water, nice. So
Air, soap and water.
air, soap, and water. So to make bubbles, you typically need a combination of air, soap, and water. So to make your solution, all you really need is soap and water. We did add glycerin to ours, which is a special ingredient that can help make bubbles a little bit thicker. So they have a little bit more stretch. And then to actually produce a bubble, you have to add in air. Air is one of the most important parts that you need to make this bubble solution actually turn to bubbles. So when you blow a bubble, do you usually see the air that's going into that bubble, or is it kind of hard to see? Usually it's a little hard. So this helps us demonstrate what it would look like if we could actually see the air filling the bubbles that we're blowing. So we're gonna try, you wanna try the big one? I say dip it back in there, get it nice and bubbly. And then we're gonna do that big one. We're gonna try to see if we can fill the big jug, the big bowl and make a giant bubble out of this one. If we're lucky, we can do it. Takes a lot of precision and skill, so wish Daniel the best of luck. We might have to do it a few times. Sometimes it isn't bubbly yet. Close. Try it again. Oh, here we go. It's working. Look at it. Ooh. It's so good. So what you're seeing is that bubble solution that we've made is filling with air. It's filling with this white carbon dioxide gas that we can actually see. And what it's doing is that air is putting pressure on the edges of that bubble film. It's pushing them out. It's stretching that bubble film until it pops. And once it pops, obviously that bubble is a goner. But this helps us see how air moves as it pushes and expands a bubble just by using pressure and gas. So invisible gas from our breath does the same thing, but this white carbon dioxide gas is a lot more fun to watch. We got another one. Let's see. When is it going to pop? We've got 3 going. Which one do you think is going to pop first? Oh, this one redid itself. All right, let's get this big one. It's still going. Isn't this amazing? So this bubble, this glycerin soap water bubble is filling. Oh, and there it goes. So a little bit more science in the bubble. When you think about a bubble, you've got your soap and your water that makes up your bubble, and it's filled with air on the inside. Now there's a little bit of science happening. If we could zoom in onto the microscopic level to see the film of a bubble, that thin invisible film, this is what's happening. The film of a bubble is made up of 3 layers, kind of like a sandwich, but a sandwich you don't want to eat, because this sandwich is a layer of soap molecules, a layer of water molecules, and a layer of soap molecules. In order to make a bubble, this water layer has to be safely sandwiched between 2 layers of soap molecules. Now, water alone doesn't really make bubbles, but when you have these soap molecules, it allows that water to be protected as the soap molecules stretch further than water would ever allow. So it's this nice little blanket of soap molecules protecting the water that allows it to have all of this stretch.
Almost looks like you're
I thought you were gonna make 2, that was cool. But this is what allows that bubble to stretch and flex, is this little sandwich of soap, water, soap. So this is the microscopic, what's happening at the smallest level in our bubbles. And that's what allows them to have so much stretch and flex, even as we add all of this pressure to it. Bring this one over. All right, so it's a pretty simple demonstration today, and that's mostly it. But we are gonna open it up for questions if you have any. And while you ask, Daniel and I are just gonna make some more. If you have any questions, feel free to type them into the chat about dry ice or about bubbles, or we'll keep it in those 2 categories today. Yes.
This is my question. Can you get a bubble off of the thing, like in your hand?
Ooh, the question is, can we get a bubble off of the container and like into our hands? Daniel, do you think we can?
I don't know. That's right.
I have an idea of one way we could maybe do it, but I feel like it's gonna get messy. So we're gonna see if we can grab a bubble from the top. But I think to do it, ooh, I like this method. So first we have to get our bubble to form. This one's filling too quickly. Ooh, Daniel got one.
Can you get dry ice at the store?
Can you get dry ice at the store? Yes, some grocery stores have it. We get it from like a special store that has like industrial grade dry ice. All right, I'm gonna see if I can get this one by using my hands. Oh, so close. I've picked it up. Ah!
Oh,
All right, are there any other questions? Keep asking them if you have them while we try this fun little challenge. Oh, so close. Yes.
How do you breathe dry ice?
We have a question. How do you
breathe CO2?
How do you freeze carbon dioxide gas? You have to have special machinery to do it, where you get really, really cold, down to -109. And they also add a lot of pressure. And that increase in pressure and that drop in temperature condenses the carbon dioxide gas into these blocks. And then they squish them into kind of like ice cubes.
yes, pressure.
So it's very fancy. It's something like you can't do at home that I know of. I'm sure you could if you worked in a factory.
Why does dry ice make steam?
Why does dry ice make the steam? Because it's happening so quickly. There's a lot of carbon dioxide gas packed into that little ice cube that you see. So even though the ice cube is small, let's look at this one. So even with a cube about this small, there's a lot of carbon dioxide gas that was used to make this one ice cube. It's condensed so much. And so there's a lot of carbon dioxide gas packed into this little cube. So when you do sublimate it back into a gas, it's creating so much carbon dioxide gas so quickly that it looks really thick. And it's also very cold. So the water vapor that's at the top is also getting mixed in, and it's cooling and making that almost like a fog effect, because when water cools, it also can create kind of this little cloudiness. But mostly it's because there's so much carbon dioxide gas packed into each cube that as it sublimates, it's like really thick. Just picking them up. I did put some soap on my hands. I was trying to get this one with soap on my hands. I think the hard part is getting it to not pop when I do that. It's a hard one.
Why can you grab the plastic bubble thing when you can't grab it with your hand? Hot or not?
I don't know. Because usually, so because of that, remember that soap layer, as long as you have soapy or wet hands, you're not breaking that water molecule or that soap barrier. So the soap molecules, I got it! I did it!
Yes.
I did it! Look at it! I'll pop it.
Wally and Noah want to know, what is the proper way to dispose of dry ice?
Ooh, what is the proper way to dispose of dry ice? That's a good question. If you have too much dry ice in like a room and it sublimates really quickly, that can cause the person who's in the room, if you breathe that too heavily, that can be dangerous to you because it's too much carbon dioxide. We don't want to breathe in carbon dioxide, we breathe in oxygen. So when you dispose of dry ice, typically what I like to do is I like to put it in the sink and I like to just get it wet with water. And then it creates like a really spooky effect in my sink, which I'm a fan of. Or you can just leave it in the freezer. Eventually it'll sublimate away and it'll disappear. Just like these ice cubes I put on the table, they're just kind of shrinking. But you want to make sure, however you use dry ice, if you're working with it or disposing of it, you want to do it in a room that's really big and has a lot of air, because that will help blow the carbon dioxide gas out of the room so that you're not breathing too much of it in. So the main thing with dry ice is that you don't want to breathe the gas in like a big inhale, but it's okay to be in a big open space with it like this. So that's kind of the pointer. But once it sublimates out of the water, that's pretty much gone. So if you're using it for an experiment or for a special effect, usually once you're done using it, you don't have to worry about it too much because it kind of disappears. Boop, boop. All right, any other questions that we might have? Look at these giant bubbles. Do you think we could pick that one up with our hands? I feel like that's too big.
Do it.
Let's see if we can try it. All right, friends. Well, as we are closing up for today's live science demonstration, then once again, I just want to remind you that we do have a bunch of online events happening. We also have some STEM events such as this that we're bringing to you for free. So if you can, go ahead to www.chabospace.org and click donate. You can help support all of the programming that we're providing during this time because we are trying to make sure that we're still in a way open, even if we're not fully open. So feel free to support us any way that you can, and make sure to tune in again next week. We're going to be doing this for our final episode next Tuesday, August 18th at 11 a.m. to 11:30. And we may pick it back up. We're just going to take a little break and replan, and we might continue this in the fall throughout the school year. So if you're joining in from a class or if you are joining in with your class, don't worry, we have more live science coming your way throughout the school year. So we're going to have some fun with that. Do we have another question?
Somebody was asking why the top part is white and not the same color as the bottom of the water.
Ah, yes. Why is the top part white and the bottom is colored? I'm not exactly sure. I just know that the color of the dye has no effect on the carbon dioxide gas. I've never really thought about it too much.
Doesn't it look like from here that bubble is a little bit more blue and that bubble is a little bit more red? Probably just reflecting the light.
Yeah, the colors of the bubbles themselves, if they do change because of the dye, it's only slightly, but it's usually fairly difficult to tell because that bubble film is so thin, it's almost invisible. It's very hard to see. All right, friends, any last questions?
CO2 is bad for the atmosphere. Since dry ice is CO2, is it bad too?
All right, we had a question that carbon dioxide is bad for the atmosphere. Does that mean dry ice is bad for the atmosphere as well? That's a good question. Usually dry ice, when it's, what's the word I'm thinking of? A product of burning fossil fuels like coal, oil, and gas, that can be bad for the atmosphere because it adds a lot of extra carbon dioxide into the atmosphere at really big amounts. When we do a demonstration like this, it's a fairly minor impact because there's so little carbon dioxide gas that we're adding. But if everyone were to take dry ice tomorrow and we all did an experiment with dry ice across the entire world, that might have an effect on the atmosphere. But typically, the measure of carbon dioxide in the atmosphere that's causing impact is like dry ice effects or carbon dioxide outputs from like large factories or planes or cars or trains that are going millions of miles across the country and producing tons and tons of carbon dioxide gas. Whereas here, we're producing just a little bit. But it is good to think about, and it's something to consider of how the same ingredient or the same chemical makeup we're working with here could have larger effects on a larger scale. So that's a really good question. All right, friends, we're gonna cap it at that. I just want to say thank you all so much for joining us. Can everyone give Daniel a big thank you or a round of applause from home for helping us out? Super fun to have Daniel here as part of our Galaxy Explorer program, which is our teen program where they help do demonstrations and help teach science to our audiences. So we want to thank you all for helping support programs like that as well. And we will hopefully see you next week, Tuesday, 11 a.m. for our last episode for a little while. But for now, stay curious and stay safe, and we'll see you next time. Bye.